Hi guys, we're going to talk about inverse trig functions right now. So lesson 67. We use inverse trig functions to find angle measures. So for an example, if we were asked to find all the values of inverse sine of root 3 over 2, we would go to our unit circle and find every value with a y value of root 3 over 2, because if you recall, sine correlates to y. So on our unit circle, if we're looking, when we get to pi thirds, it has a y value of root 3 over 2. And then if you go to 2 pi thirds, it also has a y value of root 3 over 2. So for this particular problem, the inverse sine of root 3 over 2 would mean pi thirds and 2 pi thirds. This plus 2 pi n means that we can go around our circle any amount of times as long as it's a coterminal angle. So pi thirds plus any amount of times around the circle, and 2 pi thirds plus any amount of times around the circle. That n value stands for the number of times you move around the circle. In that last example, we had two answers. We had the pi thirds and we had the 2 pi thirds. When we go to answer, though, we need to restrict our range so that we only have one answer. If you ever go to use your calculator already assumes all of these rules. But here is what we're looking at. So for the inverse sine, that is denoted sine with a little -1 of your value. So inverse sine of A, we know our theta value, or our angle measurement, has to be between negative pi halves and positive pi halves. So I drew a little picture here. Negative pi halves would be like negative 90 degrees, and pi halves is positive 90 degrees. So when we're asked a question, we have to assume that it's either in quadrant 1 or quadrant 4. Inverse cosine then, again, similar notation. So cosine looks like a -1 power, but we say inverse cosine. Our theta value, or our angle measurement, has to be between 0 and pi. So 0 degrees over to pi, which correlates to 180 degrees. So it'll be in the first or second quadrant. Inverse tangent is tan with a little -1. So inverse tangent has to be between negative pi halves and positive pi halves. This is different here. It can't actually touch either this negative pi halves or the positive pi halves, because those y values, those x values are 0. And tangent, if you recall from a previous lesson, is y over x. So it can't touch these points because we would have undefined. We would be dividing by 0. But these are our restrictions on our ranges. So we want to keep these in mind. If we're asked a question without a specific range, we will resort to these three rules. A lot of times, though, let's go through this example first. So here's an example. We're going to find each inverse trig function that exists. So tangent of -1. Well, tangent of -1 is sine over cosine. So we're looking for a y value over an x value. With that being said, in order to take y over x and come out with a -1, we know that our coordinate point has to be opposites. So we're looking on our unit circle where our coordinate point is opposite. We also know we have to stay between negative pi halves and positive pi halves according to that rule we just used. So looking at a unit circle, we know we're restricted to these two quadrants. We're looking for an xy coordinate point that has very similar values. Well, in quadrant 4, we have root 2 over 2 comma negative root 2 over 2. And if we went to find tangent, which remember is y over x, or sine over cosine, we would take this negative root 2 over 2 divided by root 2 over 2. Well, you're essentially dividing the same thing by one another. They just have opposite signs. So when we divide y over x, we would get -1. So the answer to this question, the inverse tangent of -1 would be negative pi fourths. Okay, inverse cosine of 2 means we're looking on our unit circle. Cosine correlates to an x value. So we're looking on our unit circle for an x value of 2. If you look around, the largest your x value will ever get is 1. Therefore, this is undefined. Okay, your cosine and your sine will never get larger than 1. or smaller than -1. So this one is undefined. We can look at a little more complicated examples where they're actually equations. And when they're equations, we need to solve for this trig function first. Generally, when we're given these equations, they will also give us a specific interval. If they give you a specific interval, you can disregard the intervals we just defined. Okay, so those intervals we just defined for the range will be used if a specific interval isn't given to you in the particular problem you're working on. So let's solve this. We have 2 cosine theta equals √3. Our goal is to get cosine of theta all by itself, so we're going to divide by that 2, giving us cosine of theta equals √3/2. Now we need to solve for theta. This is where that inverse comes in. So we're going to take inverse cosine of √3/2, which on your unit circle, you're looking for an x value that equals √3/2. And remember, this time we can go anywhere between 0 and 360. So looking at this circle, when we get to 30 degrees, we have an x value of √3/2. And then all the way around to 330 degrees, we also have an x value of √3/2. Or more specifically, not an x value, but a cosine value. Therefore, our theta will be 30 or 330 degrees. Oops, sorry, you can't see that. There you go. Theta would be 30 or 330 degrees. Another one, 6 sine of theta plus 3 equals 0. And this time our restriction tells us that it can be any number of radians. So we solve by subtracting 3 first. So that gives us 6 sine of theta equals -3. Again, we're still solving for this sine of theta. Divide by 6. You get sine of theta equals -1/2. Remember, sine correlates to y value. So on your unit circle, you want a y value that is equal to -1/2. So over here on our unit circle, we would get a y value. Our first time would be at 7 pi 6. Remember, our restriction said radians. So 7 pi 6 would be our radian value. And then again, you get a -1/2 at 11 pi over 6. So our answer would be 7 pi over 6 and 11 pi over 6, or any coterminal angle to help us satisfy this restriction. We need this any coterminal angle. I would like you guys to solve this equation. So every example we've done so far, we've been able to find on our calculator, but that's obviously not going to be the case every single time. So occasionally we're going to have to, sorry, I think I misspoke. Everything we've seen so far has been found on our unit circle. That's not going to be the case every time, so we're going to have to use our calculator sometimes. So here would be a potential direction you would be given. Solve every equation to the nearest tenth. Use the given restriction. So we have 10 cosine of theta equals 6, and we want our degree value to be between 0 and 180. Solve again for cosine by dividing by 10. Cosine would be 3/5, or you could write that as a decimal as 0.6. And then we have to find the inverse. So on our calculator, we would find that inverse cosine button. A lot of times you're going to have to hit second cosine. So inverse cosine of 0.6 comes out rounded to the 10th as 53.1 degree. And since that's between 0 and 180, that's all we need to do. We're going to look at a very similar example though. Same equation, 10 cosine of theta equals 6, but this time it has to be between 270 and 360. So using our last example, we know that inverse cosine of 0.6 comes out as 53.1 degrees, but that's clearly not between our two restrictions. So on a unit circle, we have 53.1 degrees here in the first quadrant. We know we need to get down to the fourth quadrant. So if we reflect that angle over the x-axis, or do a -53.1 degrees, that will give us the proper cosine value. But now we need to figure out what is that value, because we can't say -53.1 because that's not a positive value between 270 and 360. So to find that, we're going to take 360 minus 53.1 to get 306.9 degrees. So our theta value would be 306.9 degrees.